Second derivatives. So we want to consider z equals e to the 5x plus 3y. Well, let's start by doing dz dx. We know that that's going to be e to the 5x plus 3y, and then using the chain rule, differentiating 5x plus 3y with respect to x just gives me 5. So that would be 5 e to the 5x plus 3y. And now let's look at dz dy. Well, that's going to be e to the 5x plus 3y, and then multiply by the differential of this with respect to y, which is 3. So that's 3 e to the 5x plus 3y. Now, we could choose to take this one and differentiate again with respect to x. And that would produce something we call d2z dx squared. Now, clearly, we're differentiating this function. The pattern is going to be the same. So you should be able to see that we're going to get 25 e to the 5x plus 3y. We could differentiate this one again and do it with respect to y, giving us d2z dy squared. Again, we're going to follow this pattern using this, and it should be clear that what you'll get is 9 e to the 5x plus 3y. So, now consider taking dz dx and differentiating with respect to y. That gives us something that we call dz dx dy, d2z. So what we'd do is we'd start with this, but then the differentiation would proceed like this one. So because we're going with respect to y, we'd get a 3 come out at this stage. So that would give me 15 e to the 5x plus 3y. Now let's differentiate this one, but with respect to x, which is d2z dy dx. So we're starting here and differentiating like this. So this time it would be times 5 comes out, and we'd get 15 e to the 5x add 3y. Note that d2z dx dy is equal to d2z dy dx. This will be the case for just about every function that you will meet.